The Outline of History by H.G. Wells. Book 1. The Making of Our World. Chapter 3. Natural Selection and the Change of Species. Now, here it will be well to put plainly certain general facts about this new thing, life, that was creeping in the shallow waters and intertidal muds of the early Paleozoic period, and which is perhaps confined to our planet alone in all the immensity of space. Life differs from all things whatever that are without life in certain general aspects. There are the most wonderful differences among living things today, but all living things, past and present, agree in possessing a certain power of growth. All living things take nourishment. All living things move about as they feed and grow, though the movement may be no more than the spread of roots through the soil or of branches in the air. Moreover, living things reproduce. They give rise to other living things, either by growing and then dividing, or by means of seeds, or spores, or eggs, or other ways of producing young. Reproduction is a characteristic of life. No living thing goes on living forever. There seems to be a limit of growth for every kind of living thing. Among very small and simple living things, such as that microscopic blob of living matter, the amoeba, an individual may grow and then divide completely into two new individuals, which again may divide in their turn. Many other microscopic creatures live actively for a time, grow, and then become quiet and inactive, enclose themselves in an outer covering, and break up wholly into a number of still smaller living things, spores, which are released and scattered and again grow into the likeness of their parent. Among more complex creatures, the reproduction is not usually such simple division, though division does occur even in the case of many creatures big enough to be visible to the unassisted eye. But the rule with almost all larger beings is that the individual grows up to a certain limit of size. Then, before it becomes unwieldy, its growth declines and stops. As it reaches its full size, it matures. It begins to produce young, which are either born alive or hatched from eggs. But all of its body does not produce young. Only a special part does that. After the individual has lived and produced offspring for some time, it ages and dies. It does so by a sort of necessity. There is a practical limit to its life as well as to its growth. These things are as true of plants as they are of animals, and they are not true of things that do not live. Non-living things, such as crystals, grow, but they have no set limits of growth or size. They do not move of their own accord, and there is no stir within them. Crystals, once formed, may last unchanged for millions of years. There is no reproduction for any non-living thing. This growth and dying and reproduction of living things leads to some very wonderful consequences. The young, which a living thing produces, are either directly or after some intermediate stages and changes, such as the changes of a caterpillar and butterfly, like the parent living thing. But they are never exactly like it, or like each other. There is always a slight difference, which we speak of as individuality. 1,000 butterflies this year may produce 2,000 or 3,000 next year. These latter will look to us almost exactly like their predecessors, but each one will have just that slight difference. It is hard for us to see individuality in butterflies because we do not observe them very closely, but it is easy for us to see it in men. All men and women in the world now are descended from the men and women of AD 1800. But not one of us now is exactly the same as one of that vanished generation. And what is true of men and butterflies is true of every sort of living thing, of plants as of animals. Every species changes all its individualities in each generation. That is as true of all the minute creatures that swarmed and reproduced and died in the Archaeozoic and Proterozoic seas as it is of men today. Every species of living things is continually dying and being born again as a multitude of fresh individuals. Consider then what must happen to a newborn generation of living things of any species. Some of the individuals will be stronger or sturdier or better suited to succeed in life in some way than the rest. Many individuals will be weaker or less suited. In particular single cases, any sort of luck or accident may occur, but on the whole, the better equipped individuals will live and grow up and reproduce themselves, and the weaker will, as a rule, go under. The latter will be less able to get food, to fight their enemies and pull through, so that in each generation there is, as it were, a picking over of a species, a picking out of most of the weak or unsuitable, and a preference for the strong and suitable. This process is called natural selection, or the survival of the fittest. It follows, therefore, from the fact that living things grow and breed and die, that every species, so long as the conditions under which it lives remain the same, becomes more and more perfectly fitted to those conditions in every generation. But now suppose those conditions change. Then the sort of individual that used to succeed may now fail to succeed, and a sort of individual that could not get on at all under the old conditions may now find its opportunity. These species will change, therefore, generation by generation. The old sort of individual that used to prosper and dominate will fail and die out, and the new sort of individual will become the rule, until the general character of the species changes. Suppose, for example, there is some little furry white-brown animal living in a bitterly cold land, which is usually under snow. Such individuals as have the thickest, whitest fur will be least hurt by the cold, less seen by their enemies, and less conspicuous as they seek their prey. The fur of this species will thicken, and its whiteness will increase with every generation, until there is no advantage in carrying any more fur. Imagine now a change of that climate that brings warmth into the land, sweeps away the snows, makes white creatures glaringly visible during the greater part of the year, and thick fur an encumbrance. Then every individual with a touch of brown in its coloring and a thinner fur will find itself at an advantage, and very white and heavy fur will be a handicap. There will be a weeding out of the white in favor of the brown in each generation. If this change of climate comes about too quickly, it may, of course, exterminate the species altogether. But if it comes about gradually, the species, although it may have a hard time, may yet be able to change itself and adapt itself generation by generation. This change and adaptation is called the modification of species. Perhaps this change of climate does not occur all over the lands inhabited by the species. Maybe it only occurs on one side of some great arm of the sea, or some great mountain range or such like divide, and not on the other. A warm ocean current like the Gulf Stream may be deflected and flow so as to warm one side of the barrier, leaving the other still cold. Then, on the cold side, this species will still be going on to its utmost possible furriness and whiteness, and on the other side it will be modifying towards brownness and a thinner coat. At the same time, there will probably be other changes going on, a difference in the paws perhaps, because one half of the species will be frequently scratching through the snow for its food, while the other will be scampering over brown earth. Probably also the difference of climate will mean differences in the sort of food available, and that may produce differences in the teeth and digestive organs. And there may be changes in the sweat and oil glands of the skin due to the changes in the fur, and these will affect the excretory organs and all the internal chemistry of the body, and so through all the structure of the creature. A time will come when the two separated varieties of this formerly single species will become so unlike each other as to be recognizably different species. Such a splitting up of a species in the course of generations into two or more species is called the differentiation of species. And it should be clear to the reader that given these elemental facts of life, given growth and death and reproduction with individual variation in a world that changes, life must change in this way. Modification and differentiation must occur. Old species must disappear, and new ones appear. We have chosen for our instance here a familiar sort of animal, but what is true of furry beasts in the snow and ice is true of all life, and equally true of the soft jellies and simple beings that flowed and crawled for hundreds of millions of years between the tidal levels and in the shallow, warm waters of the Proterozoic seas. The early life of the early world, when the blazing sun rose and set in only a quarter of the time it now takes, when the warm seas poured in great tides over the sandy and muddy shores of the rocky lands, and the air was full of clouds and steam, must have been modified and varied, and species must have developed at a great pace. Life was probably as swift and short as the days and years. The generations, which natural selection picked over, followed one another in rapid succession. Natural selection is a slower process with man than with any other creature. It takes 20 years or more before an ordinary human being in Western Europe grows up and reproduces. In the case of most animals, the new generation is on trial in a year or less. With such simple and lowly beings, however, as first appeared in the primordial seas, growth and reproduction was probably a matter of a few brief hours, or even of a few brief minutes. Modification and differentiation of species must accordingly have been extremely rapid, and life had already developed a great variety of widely contrasted forms before it began to leave traces in the rocks. The record of the rocks does not begin, therefore, with any group of closely related forms from which all subsequent and existing creatures are descended. It begins in the midst of the game, with nearly every main division of the animal kingdom already represented. Plants are already plants, and animals, animals. The curtain rises on a drama in the sea that has already begun, and has been going on for some time. The brachiopods are discovered already in their shells, accepting and consuming much the same sort of food that oysters and mussels do now. The great water scorpions crawl among the seaweeds. The trilobites roll up into balls and unroll and scuttle away. In that ancient mud and among those early weeds, there was probably as rich and abundant and active a life of infusoria and the like as one finds in a drop of ditch water today. In the ocean waters, too, down to the utmost downward limit to which light could filter, then, as now, there was an abundance of minute and translucent, and in many cases phosphorescent beings. But though the ocean and intertidal waters already swarmed with life, the land above the high tide line was still, so far as we can guess, a stony wilderness, without a trace of life. Just a note to the listener that this work was published in 1920, and not all of the information contained in it is still accurate today.